Good morning, everybody. How's everybody doing today? Hopefully, it's going to be a nice week. Hope everybody's doing okay. Hope no snow on the ground. How's everybody doing today? I'm hoping. Got a lot of people on. A lot of people made and said, "Hey, Mr. Noah, I want to be on. I want to be participating." All right. Okay, so first of all, I got some information. Let's take a look. Okay, the AP came out with, here's our objectives, I guess you'd say. Here's our how they're going to be working. Oh, look who's here. Good job. Take a look. Okay, take a look over here. Okay, so here's the, they put out this sheet. You can check this out. It's on AP Central. But just let's go over a couple of these. First of all, the testing date, mark a calendar for all your AP classes. The exam date for us is May 12th. And while we're on the calendar, May 13th is the last day for seniors. So that's a nice little timing. I'm sure they planned it that way because math is the most important subject. Math's the only subject that counts here. So, and our time is at 1 p.m., so make sure you're available at 1 p.m. It's here's how it's going to go. Okay, they're going to be, maybe 15 minutes early so everybody gets logged on and stuff like that. And then they drop the question. The question will start at 1 p.m. You'll have 25 minutes to read and respond to question 1, and then 5 minutes to upload the response. And we're going to practice that in maybe a week or so. After uploading response 1, the students will have 15 minutes to work on question 2, and then 5 minutes to upload that. Once the response for question 1 is submitted, they cannot go back. So remember, you can only do one at a time. So that's why they're going with 25 minutes for question 1. It'll be 60% of the test. 15 minutes for question 2 will be 40%. What I'm thinking is question 1 is going to be one of those like bathtub type problems that, you could take the derivatives, you could integrate. You can find the maximum, a lot of thing like that, but I don't know. And then I think question number 2 is going to be like, maybe series and sequences and a little bit extra. Look what they're saying here. They're saying the question will develop test knowledge and skills in 2 or more units. So they're going to be combining these a lot of different ways. Okay, remember, we have to do unit 1 through 8 for those taking a look at the objectives there, and then unit 10, which is series and sequences. And so we're going to work on unit 10 this week. Question 2, again. Question 2 is, similar concepts to calculus. Here's a couple things that they're saying. First of all, you can handwrite or you could type. Now, I would suggest you handwrite, but that's me. Okay, if you want to type it, then work on formatting and stuff like that. Start working on it now. But handwriting, just writing on a sheet of paper and then just taking a picture of it and uploading it onto wherever the format that we're going to have to upload might be the way to go there. But you could type also. So those are your choices. Here, if you remember, these are the objectives. We looked at it a couple weeks ago, where you could find those and exactly what those mean, and everybody read them and stuff like that. Remember, it does not include polars and parametrics, and it doesn't include a lot of the series and sequence stuff, only the stuff that we're working on now. The only difference between A, B, and BC is, remember, BC is, BC is unit 7 and 8. AB is not AB is 1 through 7, and BC is unit 8, which is the area and volume stuff, and then unit 10. Those are the extra stuffs for BC. And plus a little bit of extra. For example, we do separation of we do, what's that one called? Integration by parts, anti-product rule, but they don't. AB doesn't do that kind of stuff. Remember, you still got this week. You could call your counselor if you want to take AB instead of just BC, but we've talked about that a couple weeks ago. You might as well take BC. But see what your school says on stuff. Here's a couple more points to make. Okay. First of all, for students who prefer to type the response on a computer, we'll provide a keyboard tip sheet. in advance of the exams. They're going to give you that on how to do the mathematical symbols and stuff like that. And it's up to you, but I would suggest you just do it by hand and take a picture of it. Graphing calculator, take a look at this. Graphing calculator is not required. However, the use of a calculator is allowed. So if it makes you feel better, so they're probably not going to have any questions where we're going to have to find the intersection of two lines or something like that. We're probably not going to have to take a derivative or an integral. I think a lot of the test is really going to be just set up this integral, something like that, instead of actually having you evaluate the integral and things. So it says calculator is allowed, but a 4-function calculator is all you'll have to do. And then take a look at this last statement right here. No arithmetic calculation will be required beyond what can readily be done with pencil and paper. So like I said, if you take a look at that little section there, they're not going to have you find the intersection of a calculator. The calculator's not going to be, you can only integrate it with the calculator. So if they give you an integral problem, it's going to be a straightforward, ready to integrate. As always, BC students are advised to submit unsimplified numeric answers in order to avoid risking arithmetic errors. We've talked about that many times. Dana, what is it? No, they're going to have their own. Data asked about, is the iPad's going to be unlocked? Can we leave the page? I think and they haven't published this yet, but what I think is going to happen is you just have pen and paper in front of you. If you don't want to do the typeset, you just have pen and paper in front of you, and a question, at that time the question will pop up, and maybe even on the calculator. I would think a calculator, but it's up to you guys. A computer might be easier. The question shows up on the computer screen. You got your pen and paper in front of you, your calculator, you're all set to go. You write it all out, and then you just take a picture of it and drag it, or even scan it or on your printer or whatever. It'd be interesting to see. The end of this week and next week, they're going to hopefully have a practice format, not a practice problem, but just how they want them submitted and stuff like that. So I would think, just this is what I'm thinking, is just like, you want to, one of the things, this is really what I'm thinking might happen for our kid, Brian and Danny. They're using a program called Seesaw. And so, they got a workbook. And the workbook, they're, 2 apples plus 7 apples, blah, blah, blah. And then what we do is we just take a picture of it on our phones and then drag it into the submit area for their little Seesaw program, and then it uploads and it gives a picture of it. Is this what you want to send to the teacher? And you just click yes. And then, so it's pretty straightforward. And that's what I'm thinking the AP is going to do. They're not going to reinvent the wheel, I would assume. It's just going to be something like that. So what I'm thinking is you're going to have your iPads or your computer or whatever, probably even your phones if you want to, and just leave that page up with all the problems on it, and then do all your writing on a piece of paper. Now, if you want to do on the computer, if you want to do the keyboard and type stuff out, that's fine too. And there's going to be a keyboard, like it says, there's going to be a keyboard shortcut that says how you have to do that. And then if something happens, the makeup dates are right there. So pretty what we expected. Everything's pretty. If you may have any questions, just post them in the chat, and then we'll be able to talk through on those. But pretty much what we expected on that. Let's go to. Is that okay? We're going to move on while you guys are thinking about that. And if you notice on Schoology, okay, let's take a look. We're in e-learning week 4. Amazing. It's been 4 weeks of this, plus those 2 weeks of spring break and stuff. So it's been 6 weeks since I missed you guys. We can turn. Oh, you want to put it in? Should we put it in? Is it getting sent back to you? All right, I'm going to work on. Let me write that down. Hold on, Mr. Noah. I will write that down. I'll work on that today. So you want like something in Schoology where you could submit it just to practice that? All right. Is that what you're talking about, Stan? Schoology post assignments. So you could turn stuff in? Okay. I'll work on that. That'll be on the list. So what do we have in... we got week 4. This is a series and sequence week. So we're going to be working on some of these. There's 3 different problem sets, and the same thing like last week. What we'll have is today we'll just do an example problem. And like I said, a lot of these are multiple choices. Just to refresh our memory on stuff, these are the 5 objectives. If you take a look, these are the 5 objectives from the units that the AP says they're going to test you on. So you want to know these. You want to be ready for these. And a lot of them are multiple choice, and the test is not multiple choice. But just to refresh your memory on some topics, I don't know how they're going to test you there. I'm thinking the one I set up, we got a good ratio test one. They might test you on something like that. So today we'll just review all this stuff. We'll do an example one. I'll let you go to work on these. Remember, tomorrow we're not meeting online, but of course, if you have any questions, you always can email me and say, hey, Mr. No, I'm stuck on this problem. What do I do here? And then on Wednesday, so tomorrow's assignment, okay, will be same thing as last week. We're going to do the exact same thing last week. I think it worked out really well. Tomorrow's assignment is to post on Schoology. I'll put it up in the morning, and you just got to tell me one problem that you want to work on so that I could tally it and we can focus our attentions right at the beginning of Wednesday. So today is just like you're here now and going over these problems. They'll be submitted. So the 5 grades this week. Monday, Wednesday, Friday grade will be these 3 assignments. So eventually you'll have to do these 3 assignments. Tuesday's grade will be to post one question in the Schoology. I'll set up a Schoology post, and you just say, this is the problem I want you to work on. Just show me that you've looked at all these problems and you're starting to focus your attention on stuff. Thursday will be, I will post the answers, and all you got to do is look at the answers. Okay, so we're not trying to stress you out too much here. And it worked out pretty well last week. Most people did it last week, so that's what we'll do this week again also. Okay? I wanted to work on, any other questions while I'm loading stuff up? I wanted to work on, if you follow along, this is problem 10.7, 10.8, that section here. And all the way at the end, I found a good free response problem, a good ratio test one. And so let's start working through on that just to practice. So if you're following along, if you want to bring it up on your computer, it is 10.8. I could have it, it'll be really small on the screen, but we could put it up there. Let's do that. Here's the document. Let's go to our document page, and I'll toss up, here we'll keep it on this side, and I'll toss up the problem there. I'll toss that up over there in the corner. So you can see this is the one that we're working on. Okay? All right, so take a look at what we got. Okay, we got a function. It's a summation. Refresh your memory on all this stuff. We have the summation n x to the n over 2n squared plus what? And that's the function. F of x is equal to this function. And it starts at 1 to infinity. Now remember, if you're unsure, this is just a notation. Remember what we were always saying in class. If you're not sure about that, write out a few terms. The first term of the polynomial, remember this is a polynomial. The first term of the polynomial is x over 3. And then plug in 2. The next term of the polynomial for n is 2x squared over 9. You see what I mean? This is just notation for what a polynomial is. And you want to do it one more, 3, plug in 3. Okay, this is 3x to the third over 19. Dot, dot, dot. Just that's all that is. That's all that summation symbol means. And it's saying the function, whatever this function is, we haven't figured out what that function is yet, but that function is equal to this polynomial on a certain interval where r is the radius. It would like you to find the radius. Okay, now here's where your notes, your binder should be ready to go. You should have it, and you could use it on the AP test. Everything should be right there about, check your binder out, have it right in front of you. I'm pausing. And we're talking ratio test. So what are you supposed to have for the ratio test? We got the limit as n approaches infinity. We got the absolute value. Don't forget that. Okay, we got the n plus 1, x to the n plus 1 over 2 parentheses n plus 1 squared plus 1 times, now we take the reciprocal, 2n squared plus 1 over, let's keep that parentheses, n x to the n. There's the setup for your ratio test. You see that? What we're doing is trying to find r, the radius of convergence, and that's what ratio test does. All right, let's see if we can cancel anything out here. Sure, x to the n. And one of these x to the n, so all we have left is x. Nothing here. We could FOIL all this stuff out, but nothing cancels. And remember, if we multiply all this stuff out, let's just look at the top heavy, bottom heavy, even, Steven. If we multiply all this out, on top, this n, multiplied by this n, we'd have n cubed. And here, this polynomial is n squared. Multiplied by 2, combined like terms, still n squared times n is n cubed also. So if you take a look at this, we have even Steven right here. So this limit, since it's even Steven, is just the coefficients, and the coefficients are going to be on top, absolute value. The coefficients on the top are going to be 2x. And on the bottom, as I FOIL everything out, is just going to be 2. So really, this simplifies to x. Everybody follow that? And so this converges to x. And now by ratio test, the absolute value of x is less than 1, so the radius, which is r, is 1. Refresh your memory on ratio test. How'd that go there? Just a little ratio test there. Okay, now it says, does the series converge? This is part B, and remember, stop me if you're stuck. There's a little delay here, so it'll take a little bit, but just tell me if something you have a question. Determine whether the series converges absolutely, converges conditionally, or diverges when x equals r. Okay, r we just figured out was 1. So when I plug in 1, okay, everybody see what I'm saying? When I plug in 1, if I got the summation, this is part B, n equals 1 to infinity, we got 1 for x, so I got n over 2 squared plus 1. And then part C, same question, n equals 1 to infinity, I plug in negative 1 for negative r, that's what part C is saying, and I got negative 1 to the n times n over 2 to the n squared plus 1. Everybody see part B and part C? Determine whether the series converges absolutely, converges conditionally, or diverges. That's the question. Okay, so let's take a look at both of these. Now remember, how do we do this? When we're working with both of them, these are the endpoints. When we're working with both of them, we do the positive one first because of absolute convergence test. If the absolute value converges, the alternating one converges. So we're going to work on this one first. Okay, so let's see. How would we do that? Now your binder should be in front of you, and you should be looking through it. How do you tell if that converges or diverges? What's the best test we should use? You don't have to type it in, but you could say it out loud. Wake your whole family up because you're excited that we're going to use a comparison test. We're going to use the limit comparison test. Why would we use limit comparison test on that? Because it's all polynomials. When it's all polynomials, limit comparison test. If I compare this, so by limit comparison test, if I take the limit as n approaches infinity, here's the function. What am I going to compare it to? What would make it even, Steven? 1 over n. If I compare it to 1 over n, when that flips over, that's even Steven. So that limit is 1/2. Okay, now you should be refreshing your memory on this. Limit's 1/2. What did that mean? Who cares what that's 1/2? It's a number. As long as that limit's a number, limit comparison test says they do the same thing. They both converge or they both diverge. Okay, so what do we know about, let me change colors here. What do we know about the one we picked, 1 over n? Okay, 1 over n, this is a p-series. and this one diverges by p equaling to 1. That's a p series, so that diverges. P is equal to 1 right there. So then by limit comparison test, we know this diverges because they do the same thing. How's that? Everybody happy there? That was B. We'll leave that right there off to the side. Let's go to C. Again, we want to see if this one converges. And starting at 1 to infinity. Now, they did mention in the objectives, what are we going to do for this one? We're going to do alternating series test, because they did say alternating series. Alternating series is going to be on the test. So let's refresh your memory on alternating series. Is this an alternating series? Since the first part is an alternating series. This is an alternating series because I see the -1 to the end right there. Check. Second part, it needs to be decreasing. Okay, let's see if it's decreasing. So the absolute value of it, so not worried about this -1 to the end part. And again, if you're ever stuck, let's just plug in a few terms to see. 1 over 3. That'd be negative. Then it's going to be 2 over 9. And then it's going to be negative 3 over 19. It's going to be positive 4 over, what do we got there? 16, 32, 33. Is that decreasing? Okay, what do you think? Does that look decreasing to you? I got 0.3333. I got, whatever that is, 2 divided by 9. 0.222222. 3 divided by 19. 0.15. Looks decreasing. So yeah, it's decreasing. Now, how do you want to prove it's decreasing? We could take the derivative. Use a little quotient rule right there, but it's good enough to say you've considered it. Since this is an alternating series that's decreasing, and then what's the limit as n approaches infinity? Again, not of the alternating part. We could go top heavy, bottom heavy, even Steven here. This limit is 0. So you say, since this is an alternating series that's decreasing, whose limit approaches 0, this, by alternating series test, this converges. With that, how's that? So therefore, it converges, but this one diverged, so the word we use is this converges conditionally. It does not converge absolutely, it converges conditionally, because the absolute value diverged and this one converged. All right, how do we feel there? It's coming back. Okay, and let's finish the last one. Part D. All right, part D says the first 10 terms of the Maclaurin series is used to approximate f of -1. Show that the approximation is less than 1 over 100. Or no, 1 over 10. 1 over 10. Well, as soon as, what are we doing here? What are we doing? We're on f of -1. Let's plug in f of -1. F of -1 is the summation, and starting at 1 to infinity, of -1 to the n over 2n squared plus 1. There's f of -1. That's an alternating series. So approximation, we're trying to approximate the value. The approximation is less than 1/10. What is this screaming? What is this telling you about? See the dramatic pause right there? It's telling you we're talking Lagrange error. We're talking the alternating error method. Okay, so we say, okay, the value, let's see what is the value differs. We know the, I'll use the polynomial. It says the first 10 terms. Okay, so let's see the first 10 terms. We wrote down the first 3, but the first 10 terms, we'll just call it P. The first 10 terms minus the actual function at -1 is equal to an error, which is less than or equal to, now remember, since this is an alternating series, this is less than or equal to the 11th term. When I plug in, now let's double check. First term, x is 1. Second term, x is 2. Third term, x is 3. So the 11th term, x, the exponent of the x would be 11. Okay, so this is less than, let's plug in, okay, negative 1 to the 11th times 11 over 2 times 11 squared plus 1. The error is less than the 11th term when I plug in n for 11. Now that's only the 11th term because the first term x was 1, the second, if this alternated, if this was like 1, 3, 5, 7, then that wouldn't be the 11th term. The 11th term, it says use the first 10 terms. All right, let's see what we got here. We got, okay, absolute value, so that doesn't matter. 11 over, we got 121 times 2, 242, plus 1, 243. And let's use the old calculator, 11 divided by 243. Hey, look at that. That is less than 1/10. And so we say since, now here's our notation, since f of x is an alternating series that decreases and limit approaches 0. Make sure you just get the statements in there about alternating series by Lagrange error method, by Lagrange error. And then you have your nice little statement right there, which is, I kind of ran out of room there, but that is less than 1/10. Okay, so there's a free response, problem. It had, these type of things in there. Any thoughts there? How do we feel there? How are we looking there? We feeling okay there? All right, I will let you to it. There's 3 assignments up there. Start looking through them today and tomorrow. And your assignment for tomorrow is, we're not going to meet online. Your assignment is just, as you're working through these, you're going to come with questions. Post the questions. I won't put it up till tomorrow, but tomorrow I'll post the question, and all you have to do is say the question or questions, more than one, so I could tally them up. So on Wednesday, when we meet on Wednesday, we could just go right to it and head right into the problems. If you have any questions, just email me. I'm just teaching my kids. Let's see, what are we doing this week? We're reading about folk tales this week, and how the camel got its hump. That's on the docket for this week. We're also looking at nature, leaves change colors. I don't know if you're aware of that, but they weren't. So we're going to have fun. So if anybody has any questions, let me know. If I stalled long enough, no one said anything in chat. So I hope you have a good day today and get working on this. This is series and sequences, some series and sequence stuff. And refresh your memory. Have your binder ready to go. Okay? Have a good day, everybody.